So when we're doing mixtures, and again, these are notes, we're going to have one of two types. Now again, sometimes we may be looking for cost, sometimes we may be looking for percentages, and they work a little bit differently depending on which one we're looking for. But in either instance, we are going to make ourselves a handy-dandy little chart, which is going to organize everything for us, and that's half the battle in math. If you can get things organized where you want them, it makes it pretty easy. So let's see what we're going to be dealing with this time. We're going to be dealing with, let's see, 6 ounces of Pranov's Red Hot Peanuts was made by combining 4 ounces of peanuts, which cost $1 an ounce, with 2 ounces of spices, which cost $4 an ounce. Find the cost per ounce of the mixture. Okay, so let's see here. We've got some costs that we're working with. We have some amounts. You could write amount, but I use the word quantity. It just means how much of it do we have. And then multiplying those two things together will get us our total. Because if you know how much something costs and you know how much of it you have, that's going to tell you how much in total that's going to end up costing you. So basically, what we're going to do here is we're just going to fill in the blanks on stuff, and it's going to make the equation for us. Okay, so let's see what we've got here at the start. We've got 4 ounces of peanuts that cost $1 an ounce. Okay, so they cost $1. I have 4 ounces of them. So if I were to multiply that across, then 1 times 4 would mean that particular part of my mix cost $4. $4, $1 times 4 ounces. So that was my first part. My second part says I have 2 ounces of spices that cost $4 an ounce. And again, cost times quantity equals the total. So here's how we figure out the part that we're going to calculate and get to the answer on. It says find the cost per mixture. Find the cost per ounce of the mixture. Okay, well, if I look here, my quantity, there's 6 ounces total at the end. I knew that, they told me that. Well, if the 6 ounces cost me $12, how do I figure out how much 1 ounce would cost me? Divide. So 1 ounce would cost $2. I'm done. Okay, so the actual math isn't hard. I mean, it's one step basically here, and I happen to be done with this one. But I have to know how to do the setup on this to make it work. Now I want to do another one that's similar to that before I start mixing them up. So we're actually going to go down to number 4 for a minute. We'll come back to numbers 2 and 3. But I want to do one that's similar. Can't quite fit that in my screen to have them both there, but we'll get it. Same idea. I didn't quite make that as big as I wanted. Because again, we're talking about costs here. How many kilograms of Indonesian cinnamon, which costs $9 a kilogram, must be added to 7 kilograms of Thai cinnamon, which costs $15 a kilogram, to make brand M cinnamon, which costs $11. Okay, lots of wordiness here. We got a cost. We have a quantity, and again, if you like the word amount better, that's okay. It's going to be my total. Now, if some of you even want to go so far as to like label which line is which, like this is the Indonesian and this is the Thai, that might not be a bad idea. So I go, okay, so Indonesian, cost $9. Let's see here. Now, this time, now the information looks a little different. Do they tell us how much of the Indonesian there is? No, it says how many kilograms of the Indonesian. I don't know. It's X.
Why is X?
Well, because they're asking me, normally they tell me how much it costs and how much there was. Like back up here, they told me it was 4 ounces of peanuts and it cost $1, or it was 2 ounces of spices and it cost $4. They told me everything. Well, when I got down to number 4, they told me that the Indonesian cinnamon cost $9, but they didn't tell me how much.
7 kg right there?
Okay, but wait. No, the 7 kg, the 7 kilograms goes with my Thai cinnamon, which costs $15 a kilogram. So let's see what else they tell me here. To make brand M cinnamon, which costs $11. You're like, oh, this is getting kind of crazy. Well, let's see what happens, though, when we multiply this out. Let's see if we can figure this out a little bit. 9 times x is 9x. 15 times 7 is 105. So if I add up my Indonesian and my Thai, I should get my brand M. So here's what I'm going to do. I'm going to go ahead and I'm going to add these up. You're like, add them up? Well, you're like, wait a minute. So that'd be x plus 7. And if I add these up, it's 9x plus 105. So just like we did up here, cost, which we know is going to be $11 for the stuff I make in the end, times the quantity, however much of this first stuff I got, plus 7, equals my total. So this equation is going to take us a little longer, but the chart still sets it all up for us. So when we're doing these, we multiply across. We'll make a note of this here. We're going to multiply across, and we're going to add down when we need to do that. Because we even did that in number 1. So now I look at this and I say, okay, so here I've got 11 times x plus 7. And we remember from way back when, because again, our strength is our equation solving, that if I see parentheses, I have to distribute. And again, distributing is just multiplying. And now I have a choice. Now, I like getting all my x's together, and I like keeping my x's positive. So if I want to move this 9x over to my 11x side, what do I have to do? Subtract it, absolutely. So this takes a little bit of work, but that's why we take the time. Yeah, I was going to say, I'm even going to cut a little close here. I'm going to have to start writing smaller. I made my chart a little too big, I guess. So now if I want to get 2x alone, we're almost there.
Minus here.
Exactly, minus that 77. And then my last step is just going to be to divide by 2. And it looks like I would buy 14 kilograms of the Indonesian cinnamon to make this work. And I'm going to take just a second here. I will get this back to normal in a second. My focus seems to be a little off on this guy. So I'm going to try and fix him up here a little bit. That's better. I'll try and get him back in now a little closer. How are we doing? Okay, that's better. So you see, we can even set them up the same way, but they can be solved slightly differently depending on what we're trying to get done. So I'm like, okay, do I want to go up to 2 or stay at 3? Let's come up to 2. Let me scooch this down just a bit here. All right, let's see how this one sets up. For her birthday party, Callie mixed together 5 liters of brand A fruit punch and 10 liters of brand B. Aren't these just fancy names? Brand A contains 34% fruit juice and brand B contains 40%. What percent of the mixture is fruit juice? It would be nice if they were the same liters, then we could just divide by 2, but they're not. So, we'll get set up here. I will try to make my chart smaller this time so we can... Oh. So here, let's see. Our quantity would be our liters this time, so we'll just keep doing that. And in this time, instead of cost, we're going to have percent that we're working with. So that's the only thing that's going to change. Instead of having cost, we got a percentage this time. So when we do this, and again, I like labeling these, so I got brand A, brand B. We're going to do a mixture here. All right, let's see what we got. We have 5 liters of brand A. Okay, so we have 5. We have 10 liters of brand B. Okay. Brand A contains 34%. Now, 34%, I need to write that in its decimal form.
Maybe 0.34.
0.34, good. And brand B contains 40% fruit juice, so 0.40. And just like we did before, we're going to multiply those together. We're going to multiply these together. And remember, like we said down below, we multiply across, but then we add down. And what we're trying to find out is what percent. We're trying to figure out this part. So when we add down, 10 plus 5 would mean there's going to be 15 liters of punch at the end here. That's quite a bit. And 1 plus 7 plus 4 equals 5.8. So this is going to be another one that's a little bit shorter. I know I can't do that. 5.8. Holy cow, you guys got to keep an eye on me. 1.7 plus 4 is 5.7. Silly man. All right, so let's see now. What's my one step to get L by itself? Divide. So 5.7 divided by 15. And that's going to be what my percentage of my new... Now, it's not 0.38%. We know that. We got to put it back in its percentage form here. But it's 38%. So this is how cola companies make their drinks. This is how anybody that does anything with beverages makes drinks. They got to figure out how much of each type there is to be able to put in to get what they're looking for. All right, one more on the example side here. And then what I tell you what we'll do is we'll even get you set up on some of the problems with the homework on this so you know how to set everything up here. All right, one more chart. Again, make it a little smaller here so we don't run out of room like we did at number 4. All right, looks like we're back to fruit punch again here. Yep, brand A and brand B again. But let's see if it sets up the same way. Okay. How much? Oh, how much? All right, so we got A, we got B. How much brand A fruit punch? We don't know. So that's going to be X. Which is 50% fruit juice. So 0.50. Okay, we know that part. Must be mixed with 3 liters of brand B, which is 55% fruit juice, to create a mixture that is 53, which is my end. So we're like, oh, it's going to be one like number 4 again. So I'm going to multiply these guys. And I'm going to multiply these guys. And then to finish it up, to get my end value, I'm going to go ahead and I'm going to add down. So I get x plus 3. And I get 0.50x plus 1.65. And again, that's what my mixture is going to be. So just like I did when I was doing number 4, once I get the box filled up and add down and do all my other good stuff, let me just rewrite it here so I see what I'm up to. Notice the equals sign always comes in before the total sign, before we get working it, so we don't get confused and put the equals in the wrong spot. But these are always going to set up one of these two ways. So once I get here, just like we've been doing, I'm going to do some distributing. So 0.53x plus 1.59. All right, so we got the distributing out of the way here. So we want to get all of our x's to one side. The 0.53 is bigger, so we'll minus that 0.50 out. So we notice some of these get a little bit longer. So I need to minus 0.53 minus 0.50. So it's sort of like looking at it as like it's 53 minus 50 is what I'm actually doing there. So it looks like we've got here at the end, we got 0.03x equals 0.06. And if we divide by the 0.3, looks like we're going to have 2 liters of A that we need. And again, this is something that you can use when you get to the unit test even. So you'll have how all the setup works. You're just going to have to be able to do a little compare and contrast to be able to get to the right type of question. So, as I always say with these, what we're going to do for a second here is we're going to kind of take a look at the homework ones and see, okay, how are these all going to set up? Because if we get the setup done, that's the hard part. So, let's flip over here. The homework, and we'll keep making notes on the top. If you haven't, it's a good time to start. For the next homework check, this is number 4. So probably towards the end of the week we'll get one in. And you'll notice on these there's a real similar setup with these versus the ones we just did. Because if you look at the ends on these, if you look at that very last part, that's where you're going to find out how these are going to set up. For instance, if it says, what percent of the final mixture is fruit juice? And then you look back, for instance, at number 2 from the notes, and you say, oh, what percent of the mixture is fruit juice? Okay. And so you can kind of say, oh, this is going to set up the same way number 1 is. So even if you just put a little note on there like, okay, this is going to be like number 2 on the notes, just so you know how the setup's going to work and how you're going to work your answer. And what we can do is we can work our way around and figure that out on all of them. Find the cost per pound of the mixture. Find the cost per ounce of the mixture. They set up the same. So this would set up like number 1 on the notes. That's my biggest thing with these. What percent for number 3? What percent of the mixture is fruit juice? Okay, just like number 2 on the notes. And I set this up on purpose. Okay, I made this up. So on the front of the worksheet, sets up just like the first two questions on the notes did. Number 1 and 3 are like number 2 on the notes. Numbers 2 and 4 are like number 1. You'll never guess which two examples are going to work with the ones on the back. On the back, we're trying to figure out how many pounds of coffee beans must be added. How many kilograms must be added, okay? So number 5 here would be like number 4 sets up on the notes. So I'm trying to get some of you to actually start using the notes too, which is never a bad idea. And if we get you set up properly here, okay, how many kilograms must be added? Percentages sets up just like our fruit punch example. So this one sets up like number 3 on the notes because again it's using the percentages, not the weights. And if we keep that in mind, when I go to look at those last two to figure out, notice number 7 has percentages in it, just like number 6 did. So it's going to be like number 3 was in the notes. Number 8 works with the kilograms, sort of like the pounds here. That's going to work just like number 4 in the notes. So use those with your notes to kind of work through those. And that's what we're trying to look for.